Now already I have explained you the Bohr's atomic model. Now few things more it is to be needed to tell you about it. That is, as I said you, the Bohr suggested that electrons is moving in their particular, what you can say, circular path, which he considered to be as the shells or the energy levels or the orbits, we can say that. Clear? And I said you also that this energy level or the shells or the orbits, which we can say it is not discrete. It has got a particular value of its own. Alright, and it cannot be any energy level. There are infinite number of energy levels possible between two energy levels. There are infinite number of. But you don't find electrons in those energy levels. Why? Because in those energy level, energy is fractional and energy cannot be fractional. Why? Because the energy of a particular shell or an orbit is related to that of the electrons. So electrons cannot be fractional. I have told you earlier also many times this particular. Electrons cannot be fractional. So electrons is always found in whole numbers. So how an energy can be fractional? Now how we can say that? Already I have told you about it also. That is En. That is N stands for what? Number of shells. I have told you there are different shells is there, and Niels Bohr also has given the name of the shells K, L, Mn, all these things. I have discussed with you all these things. Alright, clear. So I told you also this particular formula minus 2 pi square me4 z square by n square h square. So you can see depends upon the number of shells. Here h is a Planck's constant, z is the atomic number, e is the charge of electron, m is the mass of electron, and pi is constant. We can say that. See, if you put this value, that also I said, this value in terms of joules per atom, it will be minus 21.8 into 10 to the power minus 19 joules per atom. Considering here, listen carefully, considering the value of Z as 1 and N as 1, because remember it, I told you earlier also that Niels Bohr's atomic model was based upon hydrogen or hydrogen-like species. It was not based upon multi-electron species. You will be studying this in the drawbacks of the Niels Bohr's atomic model. You will be studying it. Alright. So hence here the value of Z I have taken to be as 1 and N I have taken to be as 1. Suppose if you change the value of Z as you take it like 2 or 3, and N you take it any other value you can take it, let us say 1, 2, 3, anything. Then you will be getting the formula to be as, in that case, Z square by N square joules per atom. Alright, Z square by N square joule per atom, because here the value of Z will differ and will differ. But if you take it Z as 1 or N as 1, then I told you this particular value. Got it? So this particular value, or we can have minus 1312 kilojoules per mole. Again same thing, Z is 1 and N is 1 I am taking it. Or minus 13.6 electron volt per atom. See, I am giving why this particular values, because questions can be in any, what you can say, unit. The energy can be given in any unit, so you need to solve accordingly. So you need to remember this value. Alright, so hence these values are known as energy in the ground level. In the ground level, the first level is considered to be as a ground level. In a particular atom, we are having the nucleus, and the first shell is considered to be the energy in the ground state. Because the lowest attainable energy is this particular value. The energy in the first state is considered to be as, or energy of the first state, I am saying the first shell, or the energy of the first orbit, we can consider to be as this particular value. Clear? The energy of the first shell. So hence that is the lowest attainable energy. The lowest attainable energy of a particular atom. We cannot have lower than that, because when you are going to rise higher, when you are going to move from first shell, second shell, third shell, fourth shell, energy is increasing. Energy increases. Alright, you put the value here, N is equal to 2. Correct, N is equal to 2 here. Z1 you keep it, and Nu2 put it. So divided by 4 it will be, this value will be. So you know in negative the smaller value is bigger. Alright, try to understand that. So hence for that particular purpose, when you are moving from the first shell to the outermost shell, energy always increases. So the K shell, the first shell, always have lower energy. Alright, the K shell also have lower energy, then the L, then M, then N, in this way it goes on. So energy increases in this particular manner when you move from lower energy to higher energy. Means first shell to the outermost shell, we can say that. Alright, first shell, second shell, third shell, in this way the energy increases. So you understood this particular one. This you have to remember it. Clear? Of course, I've said in other videos also. Just I'm explaining you because I thought that I need to explain a little bit more about it. You need to understand it. So hence you can see that energy is not having any particular value, any value of its own. It has got a definite values. Hence it is said to be as energy is quantized. Now let me give an example of quantization. Let me just explain you a little bit about quantization to tell you that what is the meaning of the word quantized. For example, suppose in our place it is not there. Suppose if you are going to different cities, like suppose metro cities when you are going, so you are taking a cab. You can see in the cab a meter is there. Alright, meter, which, so if you want to go a certain distance, it runs by meter. Whatever the price it is being shown by the meter, that price you have to pay to that particular cab wala, to the driver. We can say that. So what you find is that when you are going in a cab, you will find it out in a car when you are going. You will find it out the speedometer, got it, changes. It may increase, decrease gradually. For example, if 40 is there, 50, 60, again it come back to 50. It depends, got it, upon the driving. So the speedometer of the car changes gradually. Got it? Listen carefully. The speedometer of the car, the speed of the car, it depends upon the acceleration and all those things. It changes gradually. It may increase, decrease on all these things. But the meter, alright, not the speedometer, the meter which is being attached in the cab, you understand, taxi, many of you may not be following what is cab means. It's a taxi, isn't it? A meter is there which shows that how much money you have to pay when you come down, alright, to a certain place, alright, clear? When you arrive to a certain place, then you see the meter and you pay the money to that particular driver, as I said you. So that it changes, fixed according to fixed amount. Let us say that it is being fixed according to a rupee. So after every rupee, it changes. What changes? The value changes. So there the value changes, the value is quantized. You don't have fractional value yet. Like you cannot have, let us say 2 rupees 10 paisa. No. After 2, the next value will be 3. Then after 3, it will be 4. Let us say the meter, the meter in the cab is fixed according to 1 rupee. The difference between this 1 rupee. Alright, or let us say difference is 5 rupees, or let us say difference is 10 rupees. You know that if you go in metros and all those things, if you just enter into the cab and you come down, you have to pay a certain amount of money. Let us say 50 rupees, it's fixed. So it starts from 50, then after that it goes on changing. So there it is quantized, the value is quantized. The value does not change gradually, like 1 rupees 20 paisa, then 30 paisa, then 40 paisa, or it may come down to 1 rupees 10 paisa again. No. 1, then after that you can see the value 2, then after that you can see 3, after that you can see value 4. In this way, that is quantized. The speed is not quantized. The speed changes, increases, decreases gradually. The speed of the car, the speedometer of the car. But here, this particular value is quantized. Which value? That is the meter which is present in the car. That is quantized. That is fixed. Energy is fixed. Got it? Clear? So in this way, what you find is that the speedometer changes gradually, but the meter which is there, alright, by which you are the fare meter, that is said to be S. Alright, that changes, what you can say, to a certain value, that is quantized. It does not have any value of its own. It does not have any fractional value. It has been measured in that particular way. You will say, no, I will not give. Don't give. No problem. Don't go to the car. You go buy something else. Alright, but that is being done in, that is being fixed in that particular way. That is being changing in that particular way only. That is being changing. Alright, so in this way, it is being arranged. The things are arranged in this particular manner. Alright, fine. Now, next, after that is the meaning of the word quantized. Means the energy is fixed. It cannot have any fractional value or any value of its own. So for that reason I said, there are infinite number of energy levels between, infinite number of shells it can be. Theoretically possible, infinite number of. But in all the cells, electrons does not exist. Electrons exist in that particular shell only, whose energy is fixed, whose energy is quantized. Got it? And here also one word I am saying that you can see in the postulates it's given that it is stationary. Energy is stationary. It does not mean that the electron is stationary. No. Stationary means the energy is fixed. Its value is fixed. That is the meaning of the word stationary. That does not mean the electron is stationary. Electron is moving around the nucleus, which I have explained you. And when it is moving on the nucleus, Niels Bohr has suggested, that it neither loses nor it gains energy. It continues to remain in the same energy level, and it continues to have the same energy what the particular energy level has. Suppose if an electron is there in the second level, then the energies of the electron will be that of the second level only. It will continue to have the energy of the second level only unless and until you provide some energy, or unless and until the electron loses energy. If it is losing energy, then only the energy is going to change. If you are providing energy from outside, then only it will gain energy and energy is going to change. Otherwise, if energy is neither lost or gained, then the electrons continues to remain in the same level with the same amount of energy. So for that reason, it is said that energy of electron is quantized, it is fixed. Got it? Niels Bohr suggested that when the electrons is moving, it is losing. No, it is not losing. That is, Rutherford said that particular thing. But the Niels Bohr said that no. When the electrons is moving around the nucleus, it is having some fixed value of energy. And which energy? Whatever the energy level is possessed by that particular, whatever the energy is possessed by that particular shell, the same amount of energy is possessed by the electrons present in that shell. Got it? Is it clear now? Now next is, what is the, when the electron is moving around the shell? Got it? So you can see it's a nucleus and the electrons is moving around the shell. Clear? So what is the distance? Suppose the electron is here in the outermost shell. So I need to know the distance of the electrons from that of the shell. That means I want to calculate the radius. So how it is calculated? Rn is equal to A0 n square by Z. N again is the number of shells. A0 is a constant, which is known as Bohr's atomic radius. Bohr's atomic radius. It is said to be S. Clear? N is the number of shells. Z is the atomic number. So what it is value? 52.9 picometer. A0, the value is fixed. Why it is called as Bohr's atomic radius? Because if N is equal to 1 and Z is equal to 1, so R1 first shell is known as N0. And I said you that Bohr's atomic theory is based upon hydrogen or hydrogen-like species. So if you take hydrogen, then what is the atomic number of hydrogen? 1. So hence for that particular purpose, here A0 is known as Bohr's atomic radius, which is considered to be as, whose value is 52.9 picometer, that is fixed. This is a constant value, A0, 52.9 picometer. Got it? How it is? When N is 1, Z is 1, then R1 means first shell. Then radius from that of the nucleus is how much? 52.9 picometer. Accordingly, as a number of shells is changed, Z will change, you will put the value and you will find it out the radius. Got it? That you can do it. Now, next is after that, you can also calculate the velocity of the electron. Suppose electron is present in the third shell. So what is the velocity of the electron in that particular shell? So V0 into Z by N. V0 into Z by N, where V0 is again constant. V0 is 2.188 into 10 to the power 8 centimeter per second. 10 to the power 8 centimeter per second. V0, again it is constant, 2.188 into 10 to the power 8 centimeter per second. See, all this constant has been calculated experimentally. By experimental determination, this value is being calculated. So Vn means velocity of the electron in a particular shell is given with the formula, that is Vn is equal to V0 into Z by N. Similarly, when an electron is moving around the shell, alright, it possesses angular momentum. I have told it in the previous video. Angular momentum. One is a linear momentum. When a body travels straight on the road, that's linear. But when you are traveling in a circular path, it's angular radius, angular velocity, all these things you have read in physics, or if not, you will be studying in physics. So in this way, there we do not possess linear momentum, we possess angular momentum. Because linear momentum is denoted by the letter P, small p. Small p is equal to mass into velocity, that is linear momentum. Alright? Here in case of angular momentum, what we do? We also take the radius. So angular momentum is nothing but P is equal to mvr. Alright, that is called angular momentum. Mind it, you will read it more about it in physics, you will be studying it. So, just like energy, remember it, Niels Bohr suggested that angular momentum, just like energy, it is also quantized. Angular momentum is also quantized. It cannot have any value, it cannot have any discrete value, it cannot have any fractional value. It's also having a fixed value. Why? Because as energy depends upon the number of shells, Alright, En is equal to minus 2 pi square Me4Z square by n square h square. It depends upon the number of shells. Similarly, we are also calculating the angular momentum of a shell, of an orbit. So it depends upon the shells. So if it is depending upon the shells, and how its value can be fractional, it is never fractional. Its value is also fixed, quantized. So what is angular momentum? I said in the formula mvr. Because m into v is linear velocity, linear momentum. When you multiply r means why you multiplied r? Because the electron is moving in a circular path. That is a radius, which I have told you. So mvr, the formula is nh by 2 pi. nh by 2 pi. For example, for the first shell, what is the angular momentum? N is 1, h by 2 pi. For the second shell, n is 2, 2h by 2 pi. For the third shell, how much it is? 3h by 2 pi. So how much is changing? In whole number it is changing. In whole number, first is h by 2 pi, then 2h by 2 pi, then 3h by 2 pi. Understood? So just like energy, angular momentum is also quantized. It cannot have any value. It has got a fixed value. We can say that. Now from where he got this particular value mvr is equal to nh by 2 pi, Niels Bohr could not say. We will be studying in the next, what you can say, concept. We will be studying it. There I will explain you from where we got it. In the de Broglie's concept, I will be explaining you from where what you can say, Niels Bohr suggested us that mvr will be nh by 2 pi. Alright, that is also another limitations of the Bohr's atomic model. The drawbacks of the Bohr's atomic model, but could not say. See, but the scientist who took it out, you will say that how the scientist? That is the knowledge. They estimated it. And their estimation was correct. Their estimation was based upon observations. Of course, they were not having the resources at that particular time to explain that how did he got this value, how did they arrive to this particular formula. The resources was not available. That is a limitation of science, I should say that. Now science is quite developed. And now the resources are available. From that resources we are able to find it out. And when we find it out that whatever the scientist said, got it, whatever they estimated it is more or less correct, as in case of Niels Bohr. Got it? You will see that many of the things which was estimated by the scientists, now when we find it out, when we derive it by experimentally, we find it's more or less correct. See their estimation, see their knowledge, see their observation, how accurate they were in their observations. Got it? That you have to learn it, you have to admire from this particular scientist. That even if the resources was limited, but still then, by their observations, they were able to get a conclusions. And that conclusion, when we match it with today, when we are doing experimentally and we are finding it out, we are finding more or less it is correct. I don't say everything is correct, but most of them is correct. That is the beauty of science and beauty of that particular scientist. We should admire their knowledge, we should admire their observations, that how correct in their observations they were. And that is, we need to learn in science. Got it? We need to understand in science. So mvr is equal to nh by 2 pi. Got it? Their energy is quantized, we can say that. It has not any value of its own, but a fixed value, we can say that. Yeah. Now next is, I will say you that you have seen it. En is equal to minus 2 pi square me4 z square by n square h square. This is a formula you have seen it. Alright. Now the question comes here, where from this negative sign comes? Why it is negative? Why energy is negative? From where it comes? I will explain you now. Listen carefully. Now, you know that when you are moving away from the nucleus, listen carefully, the energy increases. The first shell is having some energy, second shell is having greater energy, third shell is having greater energy. It is estimated, or it is assumed, that when the electron is present in the outermost shell, its energy is arbitrarily taken to be as 0. It is considered to be as 0 when the electron is present in the outermost shell. Why? Alright, because what we say, the electrons which is present in the outermost shell is a free electrons. We say it or not? The valence shell, the outermost shell is a valence shell, and the electrons which are present in it are the free electrons. You have studied in the lower classes. Because those electrons are participating in the bond formation, whether it's ionic bond, covalent bond, or whatever it is. In the chemical reactions only those electrons are participating. So hence we consider that particular energy in the outermost shell to be as 0. And moreover, when you move from negative, I said you, in negative the lower value is greater. And I said you, what is that? Suppose it is having minus 1312 kilojoules per mole. After that, when you are moving towards what? 0. Because in negative, if the value is decreasing, means the value increases. So hence from negative to positive you are moving. So negative to 0. So hence it is considered that the electrons which is present in the outermost shell, its energy is considered to be a 0. Arbitrarily, listen to my word carefully. We are considering it. The arbitrarily it is taken to be as 0. Now, when an electron is going to come from the outermost shell to the innermost shell, it will not come by itself. We have to do some work upon it. Some work has to be done. Electron has to lose some energy. Then only, I have told you earlier, the electron is going to lose and it is going to come from the outermost shell to the innermost shell. It is going to lose energy. It will not come by itself. By losing energy, what was the energy there? In the outermost shell? 0. After losing energy, what the energy will be? Negative. So hence, it's considered that the energy is negative. In the formula, you get it negative. This is one concept. Another theory you can say that. When you are moving from the outermost shell to the innermost shell, the attraction is going to increase. Definitely. Because you are coming to the nucleus is positive, electrons is negative. So attractive forces increases. When attractive forces increases, when you are coming closer and closer and closer, attractive forces increases. You need to release energy. Then only you can come closer. Attractive forces increases. Got it? Due to the increase in the attractive forces, some energy has to be lost. Then only you can reach to the lower energy level. We can say that. Clear? So hence, when the energy is lost, what was the energy in the previous? 0. When the energy is lost, then what it is? Value is negative. For that purpose, its value is taken to be as negative. For that reason, when we calculate the energy, minus sign is put at the first. We can say that. Understood now? It's very simple. When the electron is present in the outermost shell, its energy is arbitrarily taken to be a 0. From the outermost shell, when the electron travels to the innermost shell, it cannot travel by itself. It has to lose some energy, then only it will come to the innermost shell. Or when it is coming from the outermost shell to the innermost shell, the attractive forces is going to increase. Why? Because it's coming closer and closer to the nucleus. Got it? So as the attractive forces increases, it is coming closer and closer to the nucleus. What I said, as the attractive force increases, energy is released. Energy has to be released. Then only the attractive force, because due to increase in attractive force, stability increases. And stability is inversely proportional to energy. If energy is less, stability will be more. Got it? All these things related and understand it. So in this way, when the stability will increase, attractive forces increase, it is going to lose energy and hence its value initially was 0. As it is losing, its value will be negative. Got it now? So this is all about your Neil Bohr's atomic model. Thank you.